Hi everyone, and welcome to lesson 5 of Unit 4. And what we're going to get into today is reactions involving solutions. And so I've put a little note on here that says we're going to do a bit of a review of Unit 2. And in Unit 2, we did double displacement reactions, and in particular, we talked about precipitation reactions. And so this is when you put two substances together, and sometimes a precipitate would form or a solid would form. So that's what we're headed for in this, and I'll just kind of, as you think about what we're doing here, I want you to picture that you've got two beakers of solutions. Okay, so you've got two beakers, and obviously they're mainly water. But you've put something in them, and so you've put a ionic compound in them. Let's just say in this one we put some sodium, we'll say sodium sulfate, in this one. And so you add that to it, and it dissolves. It's soluble, and so you get when it falls into this water, it will break apart into its ions. Okay, so you've got a beaker there with sodium sulfate, and let's say in the other beaker we have calcium. Let's say calcium chloride. So we have calcium chloride. And I know I know the subscripts because it's a +2. Calcium's a +2 ion, chloride's a -1, so that's calcium chloride. And when I add it into this beaker, I get calcium +2 and these chloride ions. So, we use our solubility guidelines to know whether or not they're soluble. Essentially, I'm going to show you a little demo here. So if I took some calcium chloride and I added it here, and I'll add a bit more of it, I'll add some more. So basically, this is a little demo showing that, yeah, it breaks apart into its ions, and these ions just float around in the water. They don't show the water molecules, they're in behind here, but sure enough, that's what calcium chloride would do. And I'm just going to reset this for a second, and I know that it's going to do that based on looking at this solubility guidelines, because look at this. As I look to see whether something's soluble, I find the anion, or chloride in this case, and I check to see where calcium is. And if it's in the top row, which here it says most, then it's highly soluble, so it will dissolve. But if it's in the bottom row, it won't. And I just glance down there and I notice that calcium isn't there, so sure enough, I know that calcium chloride will dissolve. And let's check the other one out. The other one was sodium sulfate. Sure enough, let's look over here. There's sulfate. Most things are soluble, and let's just double check whether sodium. No, sodium's not one of those, so good. So both of these are soluble. So I've added them in, and here I'll just show you, I want to show you the other one. I showed you calcium chloride. Here I'll show you sodium sulfate. And sure enough, if I add a bunch of sodium sulfate in, it shows you that it breaks apart into its ions, and it just, these ions are going to float around in there. So that's I want you to picture that as we do our little discussion. So here we go. I've got two beakers filled with water. I added in my calcium chloride. I added in my sodium sulfate. Well, now what I'm going to do is I am going to pour these two beakers together into a bigger beaker. So here it is. I'm going to just show you a bigger beaker down here. Here they are. And I'm going to tip these. I'll tip it and pour them in. Okay. So the question in front of you now, as a chemist, is will there be a reaction? Will there be a reaction? And so this is, essentially the minute that the two mix, I want you to picture that the minute they mix, you've got these, I'm sorry, let me change my color there. So the minute they mix, you've still got them all as ions. So you've still got the sodiums here and the sulfates, and you've still got the calciums over here and the chlorines. But hopefully you recognize that pretty soon these are going to start mixing. And so that some ions are going to touch other ions. And the question you've got to ask yourself is, are any combinations of these ions going to form an insoluble compound? And if they are, then a precipitate will form. So that's kind of what we're doing in this lesson today. It's just a review of Unit 2 of these reactions. So the question is, I'm going to put a little question mark here, and I'm going to say, will any solids form? Okay, so there you go. That's the question. Well, okay, so here we go. What we've done is we've looked to make sure that both of these are soluble. And so what I'm going to write is we've checked them out, and we know that both of these, both compounds are soluble. Okay, so we've checked that out. So look what I'm going to do. I'm now going to write them. I'm going to write it as CaCl2, and I'm going to put aqueous there because aqueous means they can dissolve. Okay, and then I'm going to write Na2SO4 aqueous. And the reason why those subscripts are there, that 2 with the chlorine and that 2 with the sodium, are based on their charges. That's back from Unit 2. Sorry, Unit 1, actually. Okay, and then I'm going to put the arrow. So now what I've got to do is I've got to use my solubility guidelines and check. What I've got to check is I've got to compare the cation from this one with the anion from this one. Cation is the positive ion, anion is the negative. I got to check those, and I've got to check this one and this one. So I'm checking to see if, because I know that those ions are going to come in contact once I've mixed them, so I need to check and see whether they can form a solid. So let me check sodium and chlorine first. Well, I kind of know that one already because look at this. Sodium chloride is just salt, and I know it's soluble. So look at this. I'm gonna look under chlorine. I'm gonna look there again, and it says most things are soluble. Let me just check and see if sodium is in this lower one. No, it's not. So look what I'm gonna do. I'm gonna put an X there, and I'm gonna say no solid forms. That's a little check for me, and I put a little X there. Okay, now if I put an X here, if I were to put if that wouldn't also form a solid, then my final answer here would be no reaction. But let's double check that first. Okay, so here we go. All right. So let's check calcium and sulfate. So I go up and I'm going to check. I find sulfate. Most things are soluble. What about calcium? Oh, wait a second. There it is. So the fact that it's in the lower row there means that it forms a solid. I'm going to put a check mark and I'm going to say a solid forms. Okay, so now my prediction is that, look at this, I am going to predict that calcium sulfate, and I know that that's a +2 and that's a -2, so I don't need any subscripts here, solid forms. And then look what we do with the other one. We still write them here as part of our equation, I'm going to write NaCl, but we're allowed to write aqueous still because it hasn't formed a solid. Okay, so they're still floating around as ions. So the last thing you would do is then you would balance this, and these ones are usually pretty easy to balance, and sure enough, all I need is a 2 right there, and I'm balanced. So there's my prediction. That's my prediction of a double displacement reaction that's going to take place. Bear in mind that if you check and both of them are X's, your prediction could be that no reaction occurs. Now let's just go back to our demo just to kind of see what happens here. So here it is. We've got our sodium sulfate floating around. Now let's add in the calcium chloride. And I'm going to add a bunch of them in, and you'll notice once I've added them, you know, they're going to float around until the calciums and the sulfates collide. So there they are. They dissolve, they float around. Oh, look at that. As the calciums and the sulfates collide, they fall to the bottom as a solid, as a precipitate. Now, that's all the sulfates that were there. Here, let me add a few more. Okay, so sure enough, they'll start floating around. Notice that the sodiums and the chlorines just keep floating. You know, nothing happens, but any of the calciums and sulfates that connect will fall to the bottom as a precipitate. Okay, so that's basically what happens in these reactions. All right. Well, there's a part 2 of this. Well, here, let's actually, before we go to part 2, let's do one more example together. So it says, predict if a reaction will occur when these solutions are mixed. Okay, so I've got some pictures here for this one to show you in real life instead of just with, you know, cartoons. Okay, so here we go. Let's try this one. So it says potassium iodide plus lead 2 nitrate. So remember that a possibility here is that no reaction could occur, but let's use our solubility guidelines and figure this out. So here we go. I'm going to write Ki, and I'm quickly going to go to my solubility guidelines, and look at this. Iodide is right there, and K is not in the second row, so I know that it's aqueous. Beautiful. So I'm going to put AQ. It's soluble. And then the other one is lead, and the 2 means it's a +2 charge. And then nitrate is a -1, so I need a bracket and a 2. Let's double check nitrate. And hopefully a lot of you are saying, well, Mr. Webster, I don't even have to check nitrate because all things are soluble in nitrate. So definitely it is aqueous. Okay. So what we have to do, remember now, is check the other ones. So let's check K and NO3. Oh, and by the way, let me just show you. This is exactly what you would have here. You would have, they're showing you the Ki, and look at this. It's a clear solution. Hopefully you can see that in the picture. It just looks like a glass of water because the Ki dissolved. And here is the PbNO3, the lead nitrate, and it's dissolved. And so basically before the reaction, we've got 2 beakers that look like they just have water in them. So this is exactly what it looks like. So now what are we going to predict? So let's check K and NO3. Well, hopefully you guys will realize that when I look at NO3, nothing forms a solid. So definitely for K and NO3, I'm going to put an X because no solid will form. And then let's check Pb and I. And let's find I. There it is right there. Most things are soluble with iodine. Oh, but there it is. Pb is not soluble. So we are going to predict that a solid will form. I'll put a little check mark there. So here we go. I am going to predict that Pb let me check the charges. Pb is +2, iodide is -1, so I do need the 2 there. I'm going to predict that lead iodide solid will form, and then I'll just put the other 2 together. I'll just put K and NO3 and leave them as aqueous. So that's my prediction. Let's balance this. I would need a 2 here and a 2 here to balance it. Perfect. And I just wanted to show you this, that when you do mix those two beakers together, look what happens. It actually forms this yellow precipitate. It doesn't have to be a white it could be any color. And so in this case, look at this. All of lead iodide is a yellow solid. I'm just going to put here, it's a yellow solid is what forms. And there it is. That's kind of a neat demo, is for you to take these two clear liquids and pour them together. And the reason why they show you that second picture is that over time, the yellow solid falls to the bottom and that lead iodide sits on the bottom. Okay, so one of the things you're going to have to do in homework is just do a bunch of these predictions. And so as you're doing those predictions, you need to have this solubility guideline that's on the back of your hub in front of you and be working away with that. Okay, the one other thing I wanted to show you from this lesson, and this is a bit of a change from Unit 2, is we have a different way of writing them. And I think that, so what I think you're used to writing is what we call the molecular equation, but we're also going to learn how to write a total ionic equation and finally a net ionic equation. So I'm going to take you through an example here, and then we're going to do one more example, and then for homework you're going to have one of them to try. Okay, so first up, it says, here we go, we're going to mix sodium hydroxide and cadmium nitrate. And notice that they've already labeled them as aqueous. And so we're pretty sure that they've already looked at their solubility rules and verified that they're aqueous. So now what I'm going to do is I am going to double check. I'm going to compare sodium and nitrate, and hopefully all of you say, Mr. Webster, don't even go check it. I know that that's not going to form a solid because nothing forms a solid with nitrate. But let's check cadmium and hydroxide. Let's check those. So I'll go back to my solubility guidelines. So there's hydroxide. And I've got my periodic table. I've found cadmium. Cadmium is a transition metal. And so it's not in group 1, and it's not any of those. So definitely cadmium is not soluble, cadmium hydroxide. Okay, so I can make my prediction now. I'm going to put a check mark there to remind me that solid forms. Okay, so here I go. The charge on cadmium is +2. And so I'm going to come on over here and I'm going to predict that cadmium hydroxide, and I'm going to need to put my subscript there because cadmium's +2, hydroxide is -1, solid will form. And then I'm just going to put the other two together, and I'm going to say it's sodium nitrate, and I'll leave it as aqueous. So that's nothing new. That's what we were doing in the first part of this lesson, is we were just predicting. Let me make sure we're balanced. I notice that we've got, I need to put a 2 here, and I'm balanced. Perfect. Okay, so step number 1 is to write that molecular equation. Okay, but step number 2 is to write what we call the total ionic equation. I'm going to try to leave the two of them on my screen here so you can see this. But look at what we're going to do. Is basically anything that is aqueous, we are going to write in their ion form, because in a way, it's a better indication of what we're actually looking at, is that they're not attached, they're actually separated into their ions. So look at this. Look what happens when I go to write sodium hydroxide. So the 2 out front applies to both the sodium and the hydroxide. So look at this, and I'm going to put the charge in there. So 2 sodium aqueous and 2 hydroxide aqueous. Now for the second one, there's nothing out front. So look at this, it's just cadmium 2 plus aqueous, but the 2 that was the subscript with the nitrate now comes out front, and it's 2NO3 minus aqueous. All right, so that is the reactants written in their total ionic form. Now, let's go to the products. So here we go. Because this one is a solid, I don't break it up. So look what I'm going to do. I'm going to write cadmium hydroxide solid. I don't break it up, but the second one I am going to break up. So look at this. I'll just get rid of this just for a second. Okay, so here we go. It's 2Na plus aqueous plus 2NO3 minus aqueous. So we've broken it up. Now, one thing I want to emphasize here, it's important to notice that the coefficients in front of all of the ions, we have to have, and sorry, there's a little spelling error there. We have to have the same number of elements on both sides. Like this total ionic equation still needs to be balanced. So look at this. Notice that I've got 2 NAs here, and I've got 2 NAs here. I've got 2 NO3s here. I've got 2 NO3s here. I've still got 1 cadmium and 1 cadmium, and I've got 2 hydroxides and 2 hydroxides. So just be aware that you've still got to be balanced. Okay, so that's called the total ionic equation. And now for the very last step is we're going to write what's called the net ionic equation. And the net ionic equation eliminates what we call the spectator ions. So what I want you to notice here, I'm going to circle Na. And do you notice that Na hasn't changed from one side to the other? And look, NO3 hasn't changed from one side to the other. So we call those spectators. They don't participate in the reaction. They're just kind of in the background. And so I'm just going to bring them down here, and I'm going to show you that those are what we call spectator ions. Spectator ions. They don't do anything. It's like they're watching the game. They're watching the game between cadmium and hydroxide. They're just spectators, whereas cadmium and hydroxide are the players. Okay? And so notice the only thing that changes now in the net ionic is that we eliminate the spectator ions. And I'll say I'm just going to write it, eliminate the spectator ions. Okay, so that's all that happens as you go from the total ionic to the net ionic is eliminating the spectator. So all you're going to be left with is 2OH plus CD2 plus making the solid. And that's what we call the net ionic equation. Okay, so that's a bit more involved than what we did at the first part. Let's try one more together just to make sure you guys are comfortable with it. You'll only have one of these to do for homework. Okay, so here it goes. It says write the molecular, the total, and the net ionic equation for the following reaction. Okay, well here we go. So we've got iron 3 chloride, so that's plus 3 with iron, and Cl is minus 1, so it's FeCl3. And here we've got cesium, Cs, and then phosphate is PO4. Now cesium is plus 1 and phosphate is minus 3, so we're going to need a 3 there. Let's double check to make sure that they're both aqueous. So I'm going back to my my solubility guidelines, and it was cesium phosphate, and cesium is a group 1, so it is soluble. And the other one was iron 3 chloride, and I noticed that iron isn't down in the second row here, so good. They're both aqueous. Okay, so I'm going to write here AQ and AQ. So I just double checked to make sure that they were both aqueous. All right, well now what I've got to do is I've got to do a little comparison. I've got to compare, I got to check cesium and chlorine, and I've got to check phosphate and iron. All right, go back to my solubility guidelines and let's check it. So phosphate, okay, only group 1 in NH4, so iron isn't in there, so definitely iron forms a solid. Let's check the other one. It was, sorry, it was cesium and, what was it? Cesium and chlorine. Sorry about that. Cesium, and look at this, cesium is not down here. That's Cu+1, so it's not down there. Good. Okay, so only one of them forms a solid. So here we go. I'm going to put an X here to say that no solid forms, and I'm going to put a check here and say that that's where my solid forms. Now, I didn't do any in this lesson that there was no reaction, but just remember in your homework, some of them will both be X's and you'll write no reaction. But here we go. Okay, so I'm going to write, it's Fe, and it's +3, and PO4 is -3, so that's a nice one. We don't need any subscripts, and I'll write solid. And then I'm going to write plus cesium chloride, and cesium's +1, chloride's -1, and so I'm going to leave it as aqueous and no subscripts. Okay, let's balance, and as I balance here, I just need a 3 there. Okay, so that's what we call the molecular equation. It's a balanced equation, it's got the aqueous in the right spots, and it's got the solid in the right spot. Okay, now let's do the total ionic. All right, so I'll say here 2, the total ionic equation. Okay, here we go. So I'm going to break anything that has an aqueous, I've got to break up into its ions. So here we go. I'm going to write Fe +3. Remember that 3 up there told me it was a +3 charge, aqueous. And notice that there's nothing out front, and there's also no subscript, so it's just one Fe, plus the subscript here tells me that there are 3 Cl minus aqueous plus 3 CS plus 1 aqueous. I know that it's +1 because it's in the first group, plus PO4 -3 aqueous. Okay, and again, I know that that's a polyatomic ion and it has a charge of -3. Arrow. Now notice for total, I don't break up my solids, so I'm going to just leave it all together. Fe PO4 solid, it stays as a solid, but here I'm going to go plus, and then that 3 out front applies to both of those ions, so it's 3 CS plus 1 aqueous plus 3 Cl minus 1 aqueous. And let's double check and make sure everything's balanced. 3 Cls, 3 Cls, 3 CS, 3 CS, Fe, PO4, perfect. So that is your total ionic equation. And what I'm going to do is I'm going to circle the spectator ions. So that's a spectator, that's a spectator, because notice from one side to the other, they don't change. I'll just make a little note there. Those are the spectator ions. Okay. And then for the last one, I'm going to write the net ionic. And that's where we eliminate the spectator ions. And so here we go. I just write Fe +3 aqueous plus PO4 -3 aqueous makes Fe PO4 solid. And that is the molecular, the total ionic, and then net ionic equation. Okay, so for homework, you're going to do number 4. I've eliminated one of them here. I've eliminated D. We'll get into acids and bases later. And so I'd like you to just to predict whether a precipitate would form or write NR. So you're going to write the balanced equation. So really, for this one, you only have to do step 1, which is the balanced equation, or write NR. And then for here, all I want you to do is 6A, which is to do the molecular, the total ionic, and then the net ionic equation. So I want you to do all 3 of them for this one. Okay? And the answers are here. All right, you guys, good luck with that, and let me know if you have any questions.